Welcome everyone, it is 3 p.m. and it's time for the Server Room Show. This is episode 37. As always, you can listen through Tilde Radio as our newest inclusion in the batch for the Server Room Show. And as always, and from the very beginning, as through Unknown Radio. And the way since I started since episode 17, the brave ones can also watch this as a screencast or a videocast, or I don't know how you want to call it, through the links on victormadaras.freeshell.net, which practically takes you to twitch.tv/victormadaras to watch the live stream, and after you can pick the recording up from all those places you probably already know. Today's topic is I went through the show notes and I realized that I didn't do I mentioned some of these things, but I never went through with examples using my home network as much as with my ISP, using my ISP as an example. So I call it networking basics. I said part 1 because just in case if I'm not gonna fit into one episode. So the foundation of networking, switches, routers, wireless access points, and of course some physically laid cables, being it copper or fiber, based on either the distance or the speed you want to achieve, and of course together with some networking standards and protocols. One of the first building block would be switches. You can have a small network just using a switch. You don't need to step up and have a router. You can have a single switch. And those of you who might remember many years ago, centuries ago, it was even enough to have something called as a hub, which was like let's say it was a stupid switch because it had no brain and it made no decisions. So all it did, it broadcasted out the package it received on any of its ports to all the other ones except the one it received on. It didn't bother looking who the package belonged to as a destination. It only cared about not to send it back the same way it came from, and then it was already enough for those LAN parties. If few of you remember that, if you are old enough. I remember I have been invited once in my life to one. It was one of the nearby village, but it was this typical, late hours and you don't know everyone and this and that, and then I never went. And actually I always remember that one invitation that I let it slide, and I never got another one. And by the time I was brave enough or willing enough to go with my computer somewhere or anywhere, then these LAN parties in the form as it was meant to be in the beginning, with a simple hub in the middle and bunch of people sitting around in tables, and all the cables going all to the middle and playing, I don't know, Quake or whichever games we were playing on those times. I think it was mainly Quake, if I remember, because Unreal Tournament and all those things came way after. I think it was some Quake or Quake it had to be. So it could be done with a hub. So it's intelligent cousin of the hub is the switch. So as I said, it can be the basic foundation of a simplest network. So you can achieve networking with a switch. It acts as a controller, connecting computers, printers, servers to network in a building or a campus. switches allow devices on your network to communicate with each other as well as with other networks, uh, creating network of shared resources. Through information sharing and resource allocation, switches save money and increase productivity. So imagine if you can use a switch and connect two buildings on a campus or on a workplace which has different buildings, then it's enough to have one printer or one file server. You don't have to buy one on each side of the premises or to each building, even though printers nowadays we have it on each floors and everything. But that's where the money saving aspect and increasing productivity comes from, that you can reach beyond your own desk or your own department, so to say. There are two basic types of switches to choose from as far as it goes today. It started with all these cloud things. So previously we only had on-premises managed switches, and now the new thing is this cloud managed with a central simplified network management aspect, where you get a simple user interface, and you can even manage multi-site full stack management with automatic updates and through like a single pane of glass from anywhere in the world, using your computer or your browser, managing it from the cloud as simply as it sounds. And the managed on-premises switches, form of managing switches, is the one which you're more familiar with, when you have to connect to each switches individually, and you can have a tighter control what goes in and out of your switch and on your network. Probably you think that, but why not everyone switches to cloud managed switches? Why bother and worry so much about this thing? Still today, and mostly these things comes down to regulations, business and law. I remember specific cases from places I worked, that a certain client, because of the sensitivity of their data, the company I worked for handled for this client, they were even restricting that the file server we stored their data had to be without an uplink to the internet. Normally, that's how we have. So that would an easy requirement. But the second requirement was that they required this file server to be in US soil, or in a US provider or a US data center. And then on top of that, there were also strict requirement of up-to-date access logs. When I mean access logs, I mean that who has access to their data and what they do with it, because of the sensitivity. And in other cases, some companies, when it comes to managing the switches, you can just cloud manage, or they just don't even want to work with the cloud and connecting back to on-premises, because it just leaving one more door towards the outside, and being opened up to attacks. And why leave a door there if you know that someone can come through it? So if you can avoid, then why not? So I completely understand. So that's why the on-premises managed ones are still kicking in. And the next building blocks would be routers, which can connect multiple networks together. You remember, as we mentioned, that with the help of switches, you can create networks and separate networks also. So you can use a router to interconnect. Let's say you have two separate networks with a switch each, and to move in between them, you can use a router in the middle. In a quotes in the middle. They also connect computers on those networks to the internet. Means that routers are your way out to the routed internet, to your way out to the world. Routers enable all network computers to share a single internet connection, which saves money. And definitely now with IPv4, we are out of IPv4 addresses, and IPv6 is still not as mainstream as it should be, which eventually, when it happens, it will allow us to every single device we just own to have an IP address, an addressable and routable IP address, and there will be still a lot of addresses left over, but not the case with IPv4. So that's why this share a single internet connection, which not just saves money but simplifies. In this case, that my ISP gives me one public IPv4 address, and all the other computers I have behind go out through this one single public IP address with the help of NAT, the network address translation. So the router is clever, and it knows which came from where and which connection was initiated because of what and which machine, and it knows where to send back the replies, so to say, to try to say it easier. And exactly what I said, router acts as a dispatcher. It analyzes data being sent across a network, chooses the best route for the data to travel, and sends it on its way. So most of the time I imagine it as an intersection. Sometimes some people call it crossroads, like an intersection where each path in the intersection is a separate network. I mean, like I don't know, 192.168.1 dot something, and another one is a 172.16 dot something, and so on. One of this pathway even being towards out to the internet. So imagine it as an intersection. That's the best way to do it. They can connect your business to the world, protect information from security threats, and can even decide which computers receive priority over others, or give priority, for example, to voice over IP, because those systems are depending on real-time speed, so to say. It is fragile when it comes to slow speed or congestions in the traffic. So routers can prioritize certain type of traffic, like voice over IP. So you can make sure that system like IP telephony are always prioritized, and therefore people can have a conversation without any breakups or those typical packages falling in and out from the line while they're having a call. So, and other kind of traffic just can take a slower approach or even wait to be fulfilled, because it's not so important that youtube.com to be loaded the quickest on a company network, so to say. Beyond those basic networking functions, routers come with additional features to make networking easier or more secure, depending on your security needs. For example, you can choose a router with a firewall or with a VPN, or I mentioned the IP protocol communication system. Wireless access points are the third pillars of building your network. An access point allows devices to connect to the wireless network without cables. A wireless network makes it easy to bring new devices online and provides flexible support to mobile workers. An access point acts like an amplifier for your network, while a router provides the bandwidth. An access point extends that bandwidth so that the network can support many devices, and those devices can access the network from further away. But an access point does more than simply extend Wi-Fi. It can also give useful data about the devices on the network, provide proactive security, and serve many other practical purposes. It's good to know the access point supports different IEEE standards. Each standard is an amendment that was ratified over time. The standards operate on varying frequencies, deliver different bandwidth, and support different numbers of channels. A bit more about wireless networking. It is a bit similar when it comes to managing it, like as we discussed with the switches. This cloud with this cloud trend, that's the best way to say, coming into the management. You can see that the same happens in wireless systems. One of the managing approach is cloud-based deployment, if I can speak. It's very hot here. It's like 36 today, I think. This system uses the cloud to manage network devices deployed on premises at different locations. One of the example, like this Cisco Meraki cloud managed devices, which provide full visibility of the network through their dashboard, through single pane of glass, using through web browser. When it comes to an enterprise or campus, these different pieces of building blocks are easy to identify among with other additional devices, which serves different functions or purpose in the network, like firewalls, intrusion detections, intrusion prevention systems, or load balancers. But you will see that a bit further along that at the home, on a home network is not always so easy to piece this out piece by piece. Another two type of wireless networking type of management. One is the centralized deployment. That's the most common type. It's a centralized deployment traditionally used in corporates or campuses where buildings and networks are in close proximity. This deployment consolidates the wireless network, which makes upgrades easier and facilitates advanced wireless functionality. Controllers are based on premises and are installed in a centralized location. We have exactly the same centralized deployment solution with wireless controllers on each side of the road. Where I work, there is a road passing in the middle, so we have buildings on both sides of the roads, and we have some fibers running under the road, and it's a public road. And to be able to deal with wireless access points, we have a controller wireless controller on each side of the road and of the premises. Converged deployment, it's for smaller campuses or branch offices, offer consistency in wireless and wired connections. This deployment converges wired and wireless on one network device, an access switch, and performs the dual role of both switch and the wireless controller. This is closer a little bit than what probably you can see in the home network, which I will talk about through my example, that these converged devices, which in my example I will bring up, as I said, that it's not always easy to identify these single pieces of building blocks of your network when it comes to something else than like a campus or an enterprise, where all these functions are done or filled in by a single unit or a single appliance. When it comes to home network, it's many times it's a very very highly converged unit fusioning. The example I will bring up in my case, my ISP is Movistar. They use one single box. They call this the HGU, Home Gateway Unit, which includes as much as 5 different functions or 5 different devices in one single box. I will open the window because it's bloody hot here. I don't have AC in my room, and it's very hot. So the 5 devices, I show you first the picture, and the ones you looking at my screen, you can see it's a rectangular box from my ISP, and I will tell you all the pieces it comes included. One of which is the router, of course. It's marked as the one port, which is essentially where in this model the fiber cable connects from the fiber termination on the wall, and it has LAN ports, which serves as a bridged switch. So switch is the second device it incorporates. It also handles different VLANs to separate traffic, like the internet, the voice for IP telephony, and IPTV. So they are each in their separate VLANs, and of course voice has the quality of service set to have the highest priority. It also incorporates a wireless access point. It's wireless 5 on this one particular example. It's 802.11ac, and the newer models coming out with Wi-Fi 6, which is 802.11ax. It has an ATA adapter, which if you look at my screen on the photo, you can see there is one said TELF for telephony, and what it is that you can plug an analog old simple phone to this port, and it's analog to IP telephony converter. You just plug your analog phone there, and you don't have to do anything. It will work, and you can use it without knowing anything about IP telephony. I tried it, and it indeed works. And the fifth one, which maybe was easy to spot for some of you, maybe not for some others, you have seen that the incoming the one port itself was the one which set fiber optics in this example, and after we had on the switch the 4 switch ports, we had RG45 copper. So it might be missed or mistaken, but it also includes a media converter which converts the fiber optics to RG45 copper. Originally this media converter was in a separate box. I show another picture or a photo of it, and this is actually the setup I have, that I have this separate ONT box, and this converts the fiber coming in through the wall and the wall jack to RG45, and then from this ATH1, for example, of this ONT box, I connect one cable to, in my case, as you see, to my Ubiquiti Edge router, to the ATH0 port, which is serves as my one link, and the rest is very straightforward. Honestly, I like this setup because I can use only the ONT box to do the fiber to copper conversion, and I can save the other ISP router, which is not this one I have, but a similar one without the fiber part, and it's less boxes and it's less mess to keep around in the house. For a wireless access point, I also use my own two of the 82.11 AC Ubiquiti AP AC Pro, which is getting quite old now, but having two of these, um, feeding the same SSIDs, and I can do roaming between them without disconnecting or losing connection. I really like them, and I would not change them for anything. So as you see, when it comes to identifying the building blocks of your network, it's very easy on an enterprise or a campus scenario, but sometimes it's a bit more difficult in a home environment, because they consolidate everything to single box, the ISPs, because they want to keep the cost down. What are the pros and cons to use my ISP provided equipment, unless I absolutely must? The pros would be, most of the time everything is packaged up for me, and it's in a single box. It's plug and play. I don't really need to do anything. I just plug it in. It's ready to go as soon as I plug in. It's configured in theory to work optimally and efficiently, with all the settings taken care of for me. If anything happens or I experience any troubles, I just call the ISP and I have them fix it, either remotely or via they come to visit your home. Everything they said it comes with should work accordingly. I mean, IPTV service, if it comes with that, or phone calls, then you know that it should work. You expect that it should work. The cons would be, normally a one box does many function scenario. In my case, I think it's never as good as a single box for a single function scenario. I explained this in more detail when we talked about the home lab and firewalls, and having everything in a single box or having the things separate. You can refer back to that to those episodes. Indeed, it's more cost efficient, but it comes with losing of features or functions which in a single box function exist, and most often than not, the performance and the endurance of a single box, single function scenario outperforms by huge leaps a one box many function scenario. Apart from a home setting where you have, let's say, 3 to 5 users maximum, when it comes to a 6 users or more scenario, like in a small office or a small business, I don't think that these one box many scenarios can keep up with the demand. Not in routing, not in switching, and not as a wireless access point. There is no scalability whatsoever when it comes to, or expandability with these one box many scenarios, and they are neither modular or neither allow a modular scenario easily. So I cannot just add another 24 port to my switch side of the equation easily with a stacking cable to an existing 24 port switch, and just expect to be it plug and play. Whereas if I keep a single device for a single function, I have the means of with a stacking cable or whatever is intended to be modular and to be able to scale my if I need, let's say, another 24 ports. And of course you have no full control of what goes on inside the box, and or what flows in and out of that box. So mostly also the options you can change are far and few between. So I think when you weigh these pros and cons, what comes into account also is the size of your home, and as I said, the number of the users you have, and the number of devices, of course. And I love cables, so in my case, if I can plug things with cables, I will always do. And as you see, a single box for all the functions, it's not working for me. So the time is up, again a bit short on my show notes. I nearly finished, but see you everyone next Saturday.